welcome. I hope that you enjoyed all the presentations in Airflow Summit. So as Jamal mentioned, my name is Rafal Biegacz, and I'm going to deliver a talk to you on how to run Airflow DAGs in a secure way. On top of what Jamal already mentioned, I wanted to mention that I have been working on Airflow for the last year, and I'm engineering manager responsible for Cloud Composer within Google. Maybe one additional important fact for you that within Cloud Composer, we are trying to run almost the vanilla version of Apache Airflow with some small changes that were required to actually run Apache Airflow on the cloud and within Cloud Composer. So without further ado, let's basically proceed. So I'm going to mention and describe some 8 practices that you can apply to make your DAGs being executed in a more secure way. And if we could categorize those items, they could be divided into 3 buckets: infrastructure, Airflow setup, and engineering practices. During each of the practice or design pattern, I will mention to which category a given item belongs to. Before we proceed, a little bit of additional information. So this talk is based on the experience of running Airflow within Composer and on Google Cloud Platform. And the ideas presented here are mostly based on Airflow 1.10.x. Examples will be provided based on Composer and Airflow, but many of those ideas could be applied to self-managed Airflow setups that you could run on either GCP or on other clouds. And during this talk, I might mention some company and product names, and of course, those names are trademarks of the respective companies. Before we jump to the security practices that you can apply, let me introduce just a little bit of information about Airflow and how it is being run within the Composer. So here on the picture, you can see 2 GCP projects, customer project and tenant project. And Airflow components are run between those 2 projects. As you can see on the left-hand side, Airflow Scheduler, Redis Queue, and Airflow Workers are being run within customer project on GKE cluster. And as an executor, we are using Celery. On the other hand, Airflow Web Server is run within tenant project on Google App Engine Flex virtual machine. And as the database, we are using Cloud SQL Managed Service, within which we are creating MySQL instances. And such a MySQL instance constitutes Airflow database. So in the picture, you can see also other elements, like we use Cloud Logging for storing the logs from Airflow components. We are using Cloud Monitoring Service for storing the metrics related to Airflow and Composer environment. Not all the Composer components are depicted in this picture because I wanted to avoid too many days on the slide. Later in the presentation, you will be able to see a slide where we are presenting all the components of Composer. So as you can see, this Airflow configuration is relying a lot on managed services provided by GCP, like Google Kubernetes Engine, Google App Engine Flex, storage, Cloud SQL, Cloud IAM, auditing, and identity-aware proxy. So the first challenge that you encounter where you set up Airflow is how to basically keep it up to date, because you need to remember that you are running Airflow on some infrastructure components. If you are running it on virtual machines, then you need to remember about operating systems. If you are running on GKE cluster, then you need to remember about container images that you need to maintain to keep care of your Airflow instance. So it's pretty easy to set up Airflow setup, but immediately you get into the business of maintaining the Airflow from the DevOps perspective. So of course it's a challenge. what we can do about it. So of course, you can establish good DevOps practices where you basically on a regular basis check all the operating systems that you are using, and you basically are on top of all security vulnerabilities that are discovered in operating systems or containers that you are using, and of course, based on it, you need to act. The other approach that is also that is something that you should consider is basically to use the managed services that are provided to you by cloud service providers, because this might really help you in maintenance of Airflow setup. So many times those managed services basically perform updates and patching for you. So this burden is taken off of your plate. And as you could see in the slide presenting the Airflow setup in Composer, we are using quite a lot of managed services delivered to you by GCP, and thanks to that, we have this luxury of relying on Google to update the underlying infrastructure for you. The second challenge, once you set up the Airflow, especially in public clouds, is how to protect Airflow setup from external world and non-authorized users. So what we can do about it? In this particular setup, we are using Kubernetes. So the first thing that comes to mind is basically let's secure Kubernetes cluster. So what you can do here, you can limit access to Kubernetes master. You can limit access to GKE nodes. You can block direct access to Kubernetes services from the external world. And you might also think about some anti-spoofing mechanism that could prevent nodes from being able to send packets with arbitrary source IP addresses. And Google Kubernetes Engine actually provides mechanism to implement those items that I mentioned in this slide. So let's take a look how Composer does it. By the way, the things that I'm mentioning in this slide, they are perfectly applicable if you are doing self-managed Airflow on GCP, and probably others cloud service providers are providing here a similar mechanism. So Composer in general can be created in two modes, in the public IP mode and in private IP mode. In public IP mode, GKE nodes are running on virtual machines that have external IP addresses, and master is publicly available. So there is an external address associated with the master. So in this particular case, of course, we would like to avoid such a situation. So we will use the Composer in private IP setup. And once we do that, we will block access to GKE nodes from the external world, because those virtual machines used for GKE nodes, they are not going to have external IP addresses. On the other hand, when it comes to GKE master, we have actually a couple of alternatives here. We can completely block traffic to GKE master from the external world, or we can set up authorized networks, and only from those networks you will be able to connect to GKE master. And of course, if you create a Bastion computer within a virtual private cloud within which you have GKE cluster, from this Bastion host you will be able to connect to GKE nodes and GKE master as well. So here in this particular setup, we are using GKE features like private IP clusters and VPC native configuration. I provided on the right hand side of the slide the links to the information how to set up a GKE cluster in such a mode. So let's assume that we already have this setup ready. Now we have yet another challenge. Virtual private cloud belongs to some GCP project, and many users can log into GCP project through GCP console, or they can try to use Cloud SDK to connect from the command line to the GCP project resources. And of course, sometimes it is not good if, for example, people who have non-corporate accounts and email addresses try to connect to your project resources. So here we could apply an organizational policy, which is called domain restricted sharing. And this is a feature of GCP platform that you can turn on the organizational level, and all the projects from belonging to this organization will inherit this policy. And what this policy does for you. So this policy will allow only users with legitimate accounts belonging to your company domain to be able to log into your GCP project, and only those people will have access to GCP resources, whether it is Airflow setup itself or some other services that are used by your DAGs, like Dataproc service, like a BigQuery. On the other hand, people without this legitimate company account, they won't be able to log into your GCP project. And so this, in general, this organizational policy helps you to fight with any misconfigurations in Cloud IAM that you might have. So the next challenge that you might have once you are running Airflow setup is that some unreviewed code gets into the system. So in general, we have DAG developers, software engineers, data engineers, data scientists who develop DAGs, and they want also, of course, get the DAGs into your Airflow infrastructure, so the DAGs are started to be executed. Unfortunately, if we give users direct access to the file system used by Airflow workers, scheduler, and Airflow web server, you might be in a situation where basically some code that is not checked, or maybe even sometimes compromised, gets into your setup. So you would like, of course, to avoid such a situation. So what you can do in such a case, you can use Cloud IAM permissions to basically block direct access for your developers to the file system, and you can establish the following engineering practice: that all the DAG developers need to first commit the code of the DAGs into software control system. And this all the commits need to go through the security scrutiny and review process. Once the review is done and commits are approved, those DAGs are getting into the source control system, and then you could have CI pipeline that automatically deploys the newly committed code into the Airflow configuration, and now DAGs can be executed. So in this picture, you can actually see two teams doing the development. So in this particular case, those teams can even use different source code repositories, and then your CI pipeline commits the code and transfer it to the file system used by workers, scheduler, and web server. Within DAGs folder and plugins folder, you can have subfolders, and each subfolder will be dedicated to a given team. And as you can imagine, you can have multiple stages of such a process before the code gets into production. So first, the development of the DAGs is happening in development environment. Once the code is proven to work, you can set up automatic deployment to staging environment, and then to production environment. In such a setup, also, you avoid situations like a team member from team B deletes, for example, DAGs of the team A. And of course, the most important thing is that the code is always reviewed, so there will be no unreviewed code in your setup. Another challenge that you might have is that Airflow web server by default is a little bit like a compute element that parses DAGs, interprets plugins, and is actually accessible from an external network. This is a little bit problematic because if Airflow web server is actually parsing some DAGs, it can be treated as a point of leakage of the data. So what we can do about it? There is a feature called DAG serialization. So thanks to this feature, once you turn it on, web server stops processing DAGs. In Composer, we also implemented functionality of storing the code of the DAG in the database. As a result of it, web server does not need to have direct access to code of the DAGs. In addition to that, there is also in Composer a mechanism of configuring of the authorized networks from which you can access Airflow web server. As a result of those configuration options, you can actually make web server really a read-only interface. So how it works in case of Composer? So we are using community delivered functionality called serialized DAGs. In this particular case, Airflow scheduler interprets the DAGs, serializes them, and stores them in Airflow database. And Airflow web server extracts the information from the database. In addition to that, if you turn on DAG serialization in case of Composer, we are stop sharing the code of the DAG with a web server, as you can see on the slide. In addition to that, we also don't upload plugins to the file system of the web server. So thanks to that, actually, web server becomes a read-only element. And while creating a Composer environment, you can set up the authorized networks from which web server is accessible, and only from those networks, users will be able to access Airflow user interface. If need be, you can block totally access to the web server from all the networks. I think that it might be a valuable feature in case you are just focused on DAG execution and access to web server is not necessary all the time. From time to time, you can turn on access to web server if really something needs to be debugged or something like this. So this configuration is specific to Composer. We purposefully wanted to make Airflow web server really a read-only element. Another challenge that you might have when many teams are using a single Airflow instance is that other users can see my DAGs and they trigger execution of those DAGs. So what you can do about it? So we can use multi-tenancy feature of Airflow that actually separates users' DAGs. In web server, you need to configure filter by owner parameter to true. And then in the code of your DAG, you need to include a property owner, where you basically specify who is the owner of the DAG. As a result of it, when users navigate to Airflow web server, they will be able to see only the DAGs that they own. They will be able to trigger execution of them, but they won't be able to see DAGs belonging to other teams. So this functionality is fully supported in 1.10.9 Airflow and later versions, and configuration of this specific feature is not yet supported by Cloud Composer. So the next challenge that is related to Airflow is risk of data exfiltration. All the DAGs and tasks that we are programming and executing, they operate on data, and of course, within your DAGs, you are implementing ETL pipelines, machine learning pipelines, where you basically retrain your machine learning models. you generate the reports, pretty quickly your Airflow setup becomes a critical infrastructure for your company. And of course, you need to assure that the risk of leaking the data outside of this setup should be as small as possible. So what you can do about it? Before we jump to the proposed solution, let's analyze what is actually the vector of attack here. So we already talked how to secure access and block access to unauthorized users to your Airflow setup. So for now, let's assume that you already secured your Airflow instance. And now we are talking about malicious insiders or maybe DAG developers who have a bug in their code, or maybe by mistake they included some compromised code in their DAGs. Unfortunately, review process for your DAGs didn't discover this issue. So now in your production Airflow instance, you have DAGs that could be a threat to you. So an exemplary DAG could do something like this. A DAG could have tasks. One of the tasks would be doing a query to using BigQuery, and the result of the query would be stored in cloud storage. And all those things that I have mentioned are happening within authorized project. Now there is a possibility of copying the data from the cloud storage from the authorized project to the cloud storage to unauthorized project, and it can happen directly, through data copying from one bucket to the other, or even your DAG could do that. So the ideal situation would be like this: that we can define a security perimeter around our Airflow instance and all our services that we are using in our DAGs. And whenever there is a situation when data is being tried to be copied to an unauthorized project, is basically not possible. So actually, there is a platform feature within Google Cloud Platform, which is called VPC Security Controls. And you can define such a security zone within which you put all the sources of information that you are handling and processing, Airflow setup itself, and all other services running on GCP that you are using. As a result of it, even if the DAG has some compromised code, it won't be possible to copy the data to an unauthorized project. So this functionality that I'm describing right now is something specific to GCP. So now translating this concept to Airflow within Composer. Now on this diagram, you can see all other components that are used by Composer. So now we have data plane and control plane components of Composer, because it is important to put all the components in this security perimeter. So on this diagram, you can see not only cloud monitoring and logging, not only Airflow components, but also some other components that Composer uses to manage the Airflow instance for the users. So especially I can mention here, there are some GKE workload components like Airflow monitoring, Composer agent, FluentD responsible for uploading logs to cloud logging. We are also using PubSub topics and subscriptions to establish communication between the Composer components. And as you can see also in the security perimeter, we are including everything like customer resources and the tenant project resources. Once you have such a setup, you can be sure that now the risk of data exfiltration is much smaller. On the right-hand side, I included information about all the services that you need to put into security perimeter to properly configure Composer, so it is VPC-SC compliant. And on top of it, of course, you need to add other GCP services that your DAGs are using to make the setup fully VPCSC compliant. Here, this slide mentions all the GCP services that are currently supporting security VPC security controls, service controls. The number of them is 49, and the list of VPCSC compliant services growing every quarter. But definitely you can find a lot of very popular services here, like BigQuery, AutoML, Data Fusion, Dataproc, Vision API, and so on. So I think that in most of the cases you can achieve a setup that basically all the services that you need to achieve your goal are in security perimeter. So the challenge number 7 that you might encounter is that some operators rely on RSA keys that are stored in local file systems of Airflow workers. For example, SSH operator or SFTP operator. So what you can do about it? Many of those operators support actually an option not to rely on the file containing the RSA key, but on using a private key that can be passed to them from Airflow database, from connections table, where those private keys are encrypted with Fernet keys. So this is one thing to consider. Another thing is that whenever you are generating RSA keys, please don't use user accounts for authentication. Please prefer using service accounts that are non-human accounts. It's much easier in such a case to, for example, rotate credentials for those service accounts and so on. And finally, another thing that we might also take into account here is to, instead of storing the information about connections in connections table in Airflow DB, using some secret backend. And I will talk a little bit about it later. So here is an example of SSH operator. So in general, SSH operator uses Paramiko as underlying SSH Python library, and it requires either passing to it login and password, path to RSA key, or you can specify URL with RSA private key embedded in the URL. An example and snippet of the code that is shown here shows you an example when such a private key is embedded in the extra field in connections table. So if you use this, there will be one place where the information is stored. Probably it's much easier to manage rotation of the keys in such a case. Extra field, as I already mentioned, it is encrypted with the help of the Fernet key. Of course, we need to remember that many users could have access to Fernet key if they have access to Airflow configuration. But definitely storing it in the database, it's more optimal than having RSA keys being distributed in the file system in your Airflow setup. Similar situation with SFTP operator. You can use private key pass approach, which is exactly the same as private key in case of SSH operator. And again, this private key pass will be stored in extra field that will be encrypted in connections table. I mentioned that instead of using connections table in Airflow database, you can also use some other secret backends that started to be supported beginning from Airflow 1.10.10. So now you have at hand possibility to configure alternative secrets backends, like based on HashiCorp Vault, AWS SSM, or Google Secrets Manager. And the snippet of the code shown in the slide shows how to configure a secret backend for connections for Google Secrets Manager. Each cloud service provider like AWS or Google provide additional mechanisms how to protect access to their services that are responsible for storing secrets. So in case of Google Secrets Manager, it is Cloud IAM, and then you can use those additional IAM capabilities to limit access to users. Of course, your Airflow setup needs to have access to Secret Manager to be able to retrieve information from it. And a short note, Composer doesn't support Airflow 1.10.10 yet, so you cannot right now configure it. We are planning to deliver this functionality soon. But this practice that I'm mentioning here can be applied actually to an Airflow setup, whether it is self-managed or running in your private data center. And the last challenge that you might have is that Airflow components like worker, scheduler, and web server should run on security-proven containers or VM images. Many times we're pulling, just focusing on Kubernetes configuration here. Many times we are trying to pull containers from many places because they deliver functionality that we need. It's super important to remember that we need to get inside of the container just to see what is there, whether the components included in the container are updated, or maybe they have some vulnerabilities that you need to basically handle. So what we can do about it? So generally, the practice should be that only scanned and known images should be used in your Airflow setup. And there are a lot of services and products that are delivering the functionality of scanning for vulnerabilities. So, for example, Docker delivers Trust Registry, GitLab delivers container scanning service. In case of Google Cloud Platform, there is a service called Container Analysis. Once you store or upload the container image to container registry, if you turn on container analysis, it automatically is going to scan your containers on a regular basis. And another mechanism that you should consider to use in conjunction together with container analysis is binary authorization, which is basically a mechanism that assures that those known images that you already scanned and only those images are run on Kubernetes cluster. So before we describe how it could work in case of Airflow, let me show you just how container analysis interface looks like. So basically here we can see container registry with 3 images uploaded, and in the red box you can see the column called vulnerabilities, and this basically summarizes all the problems that were found by this service in your containers. Once you click the respective links, you will get more information about the vulnerabilities found in which components and what is the severity of the issues. You can analyze them and take into account and consider whether it is something that you need to act on, or you basically can live with those vulnerabilities. And binary authorization is a mechanism that works at deploy time. So whenever you are trying to run a workload on Kubernetes cluster and it needs to pull a container, binary authorization will do the checks for you. And it can start from something very simple, like you are allowing to use containers only from the repositories that you define. And you can end up in having very sophisticated attestors that basically will do additional checks on those containers. One of the popular checks is the integrity of the container. So, and I will talk a little bit about it in the next slide. So, such an attestation pipeline for container images could work like this: that you have we are starting from the left. So under point 1, we have a source control system that contains sources that allow us to build container images. Then we have a cloud build that pulls the sources and starts building the container images. You can configure cloud build in this way, so it passes additional metadata information within the image, like the key that was used to sign the image, and the information about the attestor that should be used to attest the container. So Cloud will build the image together with this metadata and publishes this container images into a container registry. We have here also KMS that provides those keys for you. So within KMS, we create signing keys, and private key is used to sign the images, and Cloud Build communicates to KMS to do that. Once the images are signed, when binary authorization starts checking your container image, it discovers which attestor should be used to attest your image, and it passes the action to attestor, and attestor verifies, for example, integrity of the container image. So how it could work in case of Airflow setup in the context of Composer. So very popular pattern for Composer users is to not only execute tasks within GKE cluster where Airflow workers are running, but also running tasks on a completely separate GKE cluster. Potentially, this cluster has some additional capabilities that the Airflow Kubernetes cluster doesn't have. So, for example, on this GKE cluster and on this additional GKE cluster, for example, virtual machines might be equipped with additional graphics card, and thanks to that, you can do machine learning tasks faster. So in such a situation, you can use GKE operator to execute a task. When you configure GKE operator, you specify which container image should be used to run your task, and this image, of course, needs to be present, for example, in container registry. And as we talked in the previous slide, let's assume that we had such a pipeline with attestation. So in our container registry now we have container images that have the information about attestation. So now when GKE operator tries to schedule task execution, the pod will request, the Kubernetes will request a container image for the pod, and binary authorization will kick in and will trigger the attestation by attestor. If attestation is positive, of course, the container image will be pulled to the GKE cluster and the task will be executed. And if the opposite happens, then the task is going to fail. But this mechanism gives administrators of Airflow the control over which container images are used within the system. And binary authorization is pretty flexible. You can decide which Kubernetes clusters. You can define different policies for different Kubernetes clusters. Okay, so this was my last slide. Thank you very much for listening to me. Do we have any questions?
Thank you, Rafal. And let me go to the questions log and see if we have any. Okay, we have a few. The first question goes, do you use Bazel / Blaze to build any deployed cloud composer? If yes, do you face any challenges with it, and are there any plans to open source that work?
No, we are not using Bazel, and we are also not planning to open source anything from this area. What we are planning to do is to open source the source code of Airflow versions that we are using within the composer, and thanks to that you will be able to see what kind of patches we applied to the vanilla Airflow source code, but you will be able to build this Airflow using common tools that are used in Airflow community.
Okay, and thank you. And the second question goes: is there a way we can have static public IPs assigned to Airflow worker nodes in shared VPC networks? We face issue that the IPs get changed every time the cluster restart, and we need to update those new IPs.
And the GK cluster is configured in public IP mode or private IP mode?
I think you can address both of them.
I don't know whether I have a good answer here. I would need to dig into it, and I don't want to improvise here.
Okay, so what I suggest is like maybe you can connect on Slack after the session and yeah, figure out the details of the questions and.
Yeah, I will follow up on this question definitely.
Sounds good. And can you elaborate a bit on owner-based web server access? How can we achieve that? I think
owner-based
web server access.
I don't know whether I fully understand the question.
Okay, so
potentially it might mean that someone, instead of using Airflow web server provided by Composer, someone is using self-managed Airflow, a web server that is running on GK cluster, but don't know if it is the intention of the question.
Yeah, what I suggest, I think it was Kiran asked, could you also connect with Rafal on Slack and maybe elaborate on your question so you can like get answers that address your questions. And
maybe one thing, if it is a self-managed Airflow web server that is running on GK cluster, then you should use standard mechanisms that are available on GK. So exposure to the internet through services, and GK services can be configured in different way. And we have also VPC, virtual private cloud firewall, to govern the access to the components. But yeah, I'm happy to follow up on Slack on this question.
Thank you. So the next question goes, is there a way to access the database programmatically to get the is post list or use the REST API with Composer?
So when it comes to programmatic access using Composer API, so there is no possibility to get to the database through Composer API. So this is the second part of the question. When it comes to accessing the content of the database, of course you can do that either from the DAGs, or you can log into GKE and run workload doing the queries to the database, and all the queries should be channeled through Cloud SQL proxy, like in this picture, and in this way you get direct access to Airflow database.
Folks are also asking if you can share the slides. Can we download them in PDF and post in the Slack channel?
Yes, I will prepare a PDF version of the slides and we'll share with everybody.
Thank you so much. And I think that's it. Do we have more questions? Oh, okay. There's another question. How do I know the tenant project used by Composer to add it to my VPCSC?
It is done for you. So VPCSC functionality discovers the fact that Composer has two projects, a customer and tenant project, and by definition includes tenant project in VPCSC. It's kind of part of the functionality of VPCSC and Composer. So in general, you should not worry about it. It's done for you. By the way, if it is not done correctly, then by definition of the security perimeter, a web server wouldn't have access to DAGs and logs stored in GCS bucket. Or the other thing, the other components that are running in Composer environment wouldn't be able to talk to the Airflow database, which is outside of the security perimeter. So implicitly, it's kind of proven that it is part of VPCSC, and you don't need, no action is required on user side to have tenant project in VPCSC.
Okay, let's see if we have more questions. And I'm shuffling between tabs, and sorry if I miss any of your questions if you post them on Slack. But again, a reminder, connect with Rafal on Slack. He'll be happy to answer any more questions. And thank you all for attending, and thank you, Rafal, for your presentation and insightful answers. And again, our next talk is going to be from Pinterest. We'll start in a few minutes, and you can stay connected where you are right now, and you will be automatically carried over to the next session. And with that, I guess it's time to wrap this session. And thank you, Rafal, again, and thank you all for attending.
Thank you very much. It was a pleasure.